So one of the things you can do when you're doing this on the 84 to make it a little bit nicer, when you go over here to calculate your linear regression, typically you have your stuff in L1 and L2. There is no frequency list. And right here where it says store, that's regression equation. What you can do is if you'll type alpha trace, you can tell it to store it in Y1. Then you don't have to copy all those nasty decimals over. Okay? So that's, I think, pretty helpful. So hopefully in both cases we're getting the same numbers. So the predicted population is equal to, let's see, 72.262. Are y'all getting the same thing?
Yes, I got the same thing.
Times the year.
Oh,
Minus
mine is not that.
I did not get that.
138,570.
Mr. Davis.
Yeah.
Hang on a second, make sure I've got the right thing in here. I've been playing with multiple ones this morning, so. Yeah?
I did not get that.
How do you find that again? Like, where'd you get those numbers?
For the regression equation? Okay, so. Boom, 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 boom. So when you just graphed them, it looked like this, yes?
Oh, I was on Stat Oct. Yes.
Right?
Yeah.
And then to get the regression equation on this, you want to go to regression right here
Oh no. And press enter.
and tell it that you want
Linear.
a linear regression. It doesn't matter which way you do it.
Oh, and then there at the bottom it shows the equation.
Yeah.
Oh my gosh, I didn't even realize it shows the equation there. I had to go to stats and do it individually.
Oh, no, if you hit the down arrow, it moves it to the, if you hit the up arrow, it's on the points.
Yeah.
If you hit the down arrow, it's now on the regression equation and it tells you y hat.
Oh, that's so much easier.
All right, has everyone got that now?
Yes, sir.
Okay, and and then on the TI, if you go into stat plot and turn it on with L1 and L2, and then you do zoom stat, which is zoom 9. You'll get the points and the line. All right, so in either case, when you're looking at this, when you first look at it, you're like, oh, this is great. This looks like a really nice, it's pretty linear. I'm hitting some of the points. Some of them are a little bit above, some of them are a little bit below. And then you're like, okay. But remember, what's the one thing you always must look at?
Residual.
You got to look at a residual plot.
So this wasn't the residual plot, even though we clicked residual?
We click regression.
Oh, regression.
Regression.
Sorry.
Yeah, they both start with R.
Wrong thing.
So we want to look at the residuals. All right. So how do you look at the residuals? Let me show you on the 84. To look at the residuals, what I'm going to do is I'm going to go back to y equals. I am going to turn off this line. So you just go over the equal sign and hit enter. I'm going to go up to plot 1 and turn it off. I'm going to go to plot 2 and turn it on. And what I want when I go into second stat plot, I want the residual. And you're like, well, where the heck am I supposed to find that? It is nicely hidden. I have to relearn this every year. I'm like, where is that thing hidden? So if I clear that out, where it's hidden is in the list. If you do second stat, there's a list of all of your lists, and residual is already there. So now if I do a zoom stat, I can see the residual. On the NumWorks, what you can do is go to the regression, hit enter. Note we can see that R is 0.994. You're like, oh, that's awesome. You look at the residual plot, and in either case, you see a very curved residual.
Re-expression will not help that, will it?
Yes, it will.
Dang it. I thought it was like a U shape, that's why I thought.
This is the residuals, not the original.
Oh, right. Wait,
If there's a U shape in the original data,
that's when it won't
the
work.
residuals are not going to help that. I mean, the re-expression is not going to help that.
Right, so I'm only looking at the original data when I'm trying to figure out if re-expression
Oh,
will help or not.
and that would be why, I'm sorry, on the homework, on B, on number 1, those were residuals, weren't they?
Yeah.
Oh, so yeah, B, you can fix that with re-expression. I'm sorry, for some reason I was thinking it was the original data.
So, for original data, you want it to be linear, like a line. For residual, you want it to be scattered.
Right, you want to have no pattern at all.
No pattern. Okay. But if it has a pattern on a residual, you can still change it. It doesn't. There's not like.
You may be able to re-express the data to help get rid of that and if we go back to the graph of the original, you can see what happens is that these are above, then below, 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 below,
yeah,
below,
makes
and then
sense.
above on these ends. So your residuals are negative in the middle and positive on the outsides.
So does re-expressing the data when you already have it like this looks really good, but on the residual plot, is it gonna mess this up? Did that make sense?
It will be, yeah, I know exactly what you're saying. It took me a second. So what's going to happen is what we're hoping to get is something with a higher R squared value and less of a pattern in the residuals.
Okay. But it's not gonna like mess this graph up.
Well, I'm going to do a different graph.
Oh.
Let me show you.
Okay.
All right. So since we're on this, I'm going to go up to the data. And first of all, I'm going to turn this one off so that I don't have to look at it, right? The way that you turn it off on here is you go to execute, go down 3 steps to show in graphs and stats, and you just click execute and it turns it back off.
Wait, could you do it again?
because I don't want to see it. So I moved up to X1.
But like, what are we turning
I don't want to see these numbers
on? Oh, okay.
on my graph. I don't want to see them anymore. I don't want to see two different graphs.
Yeah.
Okay? So then what I'm going to do is I'm going to come over here, and for X2, I'm just going to fill it with a formula. And the formula I'm going to fill it with is that X2 is equal to whatever X1 was.
Wait, how'd you do that again? Why don't I have X2 stacks?
Because you don't have anything in X2 yet.
Oh, yours is just showing it.
Yeah.
Oh, okay.
So I moved to X2. I said fill it with a formula. And I tell it to make X2 equal to X1. Notice it has to be a capital X.
Oh, darn. Oh, darn it. I'm doing it. Okay.
Got it?
No. How do you do the capital X? Oh, I see. Alpha X. No!
You do shift alpha, just like you do on a keyboard.
Shelf alpha X. 1.
Yeah.
Okay.
All right. Now,
Oh.
since my residuals had that U shape,
Mm-hmm.
right, kind of like a parabola, my first thought is let's take the square root.
Okay.
So for Y2, I want to fill it with a formula.
Mm-hmm.
And the formula I'm going to fill it with is with the square root of Y1.
Oh, is yours already in there from earlier?
Yeah, I did it earlier today. I was playing with this to make sure everything worked out.
Then you go back to graph.
All right. So on the TI, what we can do is if we go into statistics, edit, what I'm going to do is I'm going to leave L1 alone. And then in L3, I'm going to go, okay, I want you to be the square root of L2. And L2, oh yeah, is second 2.
Still, it still would matter. Is that what the residuals was?
Pardon? I absolutely can't hear you. Say it again. When you do the square root, does it not immediately open up a parenthesis? Oh, okay, that's fine. On this is a slightly older version, so you don't need it on yours. You just hit enter, and it's going to fill.
That's bad.
So now what we're going to do, if we go to stat, calculate the linear regression, I want to do it with L1 and L3. And again, I'm going to store the regression equation in Y1. And in the stat plot, I want to go back to the stat plot. I want this to be on, and I want it to be L1 and L3 now. And I'll do a Oh, the other one was still on. Let me turn that one off. And I have to go back to the y equals to turn this graph back on. Did it not save it? Hang on a second.
He said it takes a while.
Oh, I didn't tell it to calculate. I forgot. Now let's try it. So, for those of you who've been playing with this on the NumWorks, when you go in and look at, I gotta turn mine back on because I turned this off. Execute, come down. I want to see these now. Graph this bad boy. And you're like, okay, well that looks pretty linear, but there are still some above and some below.
Yeah.
Let's look at the residual plot. Notice r squared is closer to 1.
So it is a little better.
So it is a little bit better.
How do we know? Oh, did we know what it was before? I
Yeah.
didn't look. Okay.
Yeah, it was 0.98 something.
Wow. All this to get it up 1.0.
Now, the residual is curved, but there's not nearly as strong a pattern to it as there was before. The other one, it's like, well, that's very much like a quadratic. So this is better. Is it perfect? Gosh, no. Okay. That, and notice how small the residuals are.
Yeah. So that's good.
Smaller residuals, yeah.
Because it means it's closer to 1. No, that doesn't mean anything.
The smaller the residuals are, the closer.
The difference.
Right, right.
Oh, yeah, I
So remember, the residual is basically the error.
Mm-hmm.
It's the difference between what's actual and what your model predicts.
Mm-hmm. Okay.
So you want your residuals to be close to 0. So every now and then you'll see one where there's a curve of the residuals, but the residuals are so tiny that you're like, okay, I'm not going to worry about that.
So for this one,
Yeah.
this model, would it mean that if, like, in 1955, you're less likely to get an error than, like, in 1965? Because it's closer to,
Well, there's a smaller error, not less likely.
oh, smaller error. So, like, a model can be really good for some points and really bad for others?
Sure,
Okay.
that happens all the time. Okay?
Okay.
And Ariel, were you able to look at the residuals for that one also? It should look like this. So what about the scatter plot? Oh, so then if you go back to y equals, turn plot 2 on, turn plot 1 off, turn this graph off, and do a zoom standard, do a zoom, you can see the residual plot. All right. So we didn't actually do this. Discuss the appropriateness of your model.
Okay.
Since the residual plot shows a strong pattern.
So this was before we did it.
Correct. The model is not appropriate.
appropriate for the linear model, right?
Right. Our model is a linear model.
Oh, but it's not appropriate because the residual applies curve
Correct.
or has a pattern.
Okay. Okay.
Yeah, we went in that a week ago, right?
Yeah.
Okay.
All right. So we created a better model. And I don't have this. It's difficult for me to switch back and forth. But we did the square root, right?
Sure.
So the square root of the expected population, what did that end up being?
The,
How do you see
The
that?
The model,
It's
let me go
the
back.
regression equation.
it's 0.565,
0.565
and then that's like times the year,
times the year.
and then minus 1,052.28.
0.28. Okay, thank you. So this is a better model. Explain why your new model is better.
The R
Well-
squared
The
was
error is
greater.
less.
The R squared was greater.
So r squared
Oh.
is closer to 1 than our original model. So again, better, but not perfect. Any shortcomings? There's still kind of an S-shaped curve. To the residuals. But the residuals are small. So we're feeling pretty good about this one. It's not perfect, but all right, so let's take a look here. Estimate the population for the year Mr. Davis was born, 1962. What is this? The world population in millions. All right, so the square root of the estimated population is going to be 0.565 times 1962 minus 1,052.28.
Oh, sorry, it's 53.8. It's my fault.
50, I'm sorry, 53.28?
Take out the 2. 1,053.28.
Right. Okay. So remember, that's the square root of your estimated population.
So then you have to square it.
Yeah, so what do you get for this?
55.25. I did the opposite.
So the population predicted is going to be that number squared.
3,052.56.
3,000 what?
52.56.
So let's estimate the population in the year 2010. So the square root of our predicted population, 0.565 times 2010 minus 1053.28. What does that come out to be?
82.37.
82.37. Wow.
Squared would be 6,784.
6,784.
Yes, 0.82.
So that's almost 7 million people. So one of the questions is, well, how close is that? And are we going to be surprised if it's not particularly good? No, because we're extrapolating.
Oh,
Oh yeah, that's way past our
It's past our data set.
10 years.
We would expect this one to be pretty good, but we would not necessarily expect this one to be great.
okay.
It may be.
But if
All right, we'll do some more of those tomorrow.